Remind you, right? When you guys did limits, the first thing you should have done when you had a limit, at least after we got into it, was to take whatever the x value was that they had you approach, like this one was 1, and plug it in and see if you could get a specific number out of it. Because if you could plug the value in and it gave you a number, that was your answer. You didn't have to do any work for it. But in cases like this, you should have gotten 0 on the top end, 0 on the bottom, which, it's not really a number we could have done. So in the past, I couldn't have just stopped there and said, that's my value, 0 of 0, because that's not a value. You would have had to go and done the graph of it, and I think the portion of the graph you would care about where the 1 is, it kind of goes something like this. So you would have had to find that value by graphing it and then looking at your values on each side, either by doing a table or doing even the table in the calculator and just kind of scrolling through your table values until you get to right there. Okay? Basically what the derivatives do in specific cases, like especially with this case, is they kind of simplify the amount of work that you have to do. It's called L'Hôpital's rule. Looks like the hospital, right? It's L'Hôpital, but L'Hôpital's rule, okay? With this one, okay? So what this is basically going to come down to is, if I gave you that limit, your first step would be, like this is step 1, plugging in whatever the heck it's approaching. And as long as, like I said, I get the result of 0 over 0, then it would say, okay, now I can apply L'Hôpital's rule. And really, all that rule, all that stuff that was up there is saying is that if this happens, then you kind of you break that limit into two equations. Like there's a numerator and a denominator. And you just do the derivative of both of those. So I look at this one and this one separately. So I would say, I don't know, what did they have? They had it was like F or something like this. So we'll say that's F and this is G. I think that's the letter Z. So in reality, what I'm doing is I'm finding the derivative of what I've considered F now, which that's what, 2x minus 1, correct?
Yes.
Yeah. And then the derivative of what would be the denominator is just 2x. Okay, and then what you would do is, the way the rule works is you split it, you do the derivative, and then you put them back together in terms of a fraction. Okay, and then now what you've done is you've created a new fraction, and you take the value that they want you to approach and plug it in here now, and then check and see if it's okay to work with. So now I would take that value of 1, plug it in, and this will give me what? 2 minus 1 over 2, which is 1/2. So that would be what the limit is, the answer to that is. Let me do another one. And here's the thing to remember, when you're doing the derivatives, you're not doing like the derivative of the entire thing. It's not a quotient. You're splitting it up into a function that's on top and a function that's on the bottom, if it applies. But before you even apply what the rule is, like all the stuff with the derivatives, the first thing you need to do is take whatever you're approaching and plug it in. So like this would be natural log of 1 over 1 minus 1. And you plug it in to make sure that it hits like either 0 over 0 or infinity over infinity if it was like a limit approaching infinity. So like natural log of 1 is 0, 1 minus 1 is 0. So since I have that happening, that means I can apply the rule. And again, all the rule is saying is that now you split that thing into two functions. So natural log of x and x minus 1. All right? You do the derivative of both of those. So derivative of natural log of x is 1 over x. The derivative of x minus 1 is just 1. So now you take these two things, put them into a fraction again, and then to get the value of the limit, now you're going to take whatever you're approaching, which in this case is 1, and plug it in. So 1 over 1 over 1 is that. So that would be the answer for that limit. which is a lot quicker than doing the tables and all the other stuff. Okay? But like I said, this has to happen. If this part doesn't happen, then you got to go back to all the old rules you had for limits. I'd still start these, like any limits really, from where we were at the beginning till like when we get done with them, you should have always just taken whatever the x value is and plugged it in. Like that should have been the first step anyway. So like with the thing that's up there, if I plug in the x approaches 0, I'll get that, which e to the 0 power is 1. So I got 1 minus 1, which is 0, and that's 0. Okay, so if I plugged in what I'm approaching, I get the fraction that's 0 over 0, which means apply the rule. Okay, so if I apply the rule to what's up there, my numerator is that, my denominator is that one. So if I do derivative of e to the x minus 1 minus x, that should just become e to the x minus 1. Correct? Right. The derivative of that should just become 2x. So now, using the rule, I would take those. Here, actually, let me write it down. I'd write those two derivatives into a fraction. I would plug in whatever it's approaching. So that would become e to the 0 minus 1 over 2 times 0, which in this case, that will still, see, e to the 0 is 1, so I'm still going to get 0 over 0. So since I've applied the rule once, but after I applied it, I still got something that was 0 over 0, which if I get to this point, that's just going to tell me to come back up here, like where I left off, and apply the rule again. So now I'm going to where I stopped, that one derivative, and then I'm applying the derivative again. So essentially I'm doing the second derivative of the first one. So now I'm doing, so this was a derivative, and now I'm doing another derivative to get down to hopefully another fraction. So that's e to the x, and that's 2. So now I've got e to the x, and now I've got 2. So these two are going to become now what is the hopefully last fraction I'm working with. All right, so if I plug in again when I'm approaching, that's e to the 0 over 2. E to the 0 is 1, 2 stays the same. That's going to be your answer. So there's going to be a couple where you have to do it a few times.